Good evening and welcome to this Forum for Philosophy event. Because of COVID-19, we're still operating online, so thank you very much for joining us wherever you are. Our topic this evening is theories of everything, or a theory of everything. So we'll be discussing physical reductionism, philosophy of science, metaphysics, the relations between the special sciences, very possibly also the scope of the word everything. Our speakers this evening are Philip Bull, a science writer and editor at Nature, Vanessa Seifert, a postdoctoral researcher on the Metascience project at Bristol University, and Jessica Wilson, professor of philosophy at the University of Toronto. Our format will be as follows. We'll have about 55 minutes of chat between our speakers, and after that, I'll invite some questions. So we'll have about 20 minutes for the Q&A. There are two ways to ask questions. If you're watching through Zoom, you can use the Q&A function in there. And if you're watching on Facebook Live, you can pop your question into the comments. This event is co-sponsored by Metascience at Bristol University, so thanks very much to them for that. Okay, let's get going. Jessica, I'm going to come to you first. What are some theories of everything that people have floated?
Thanks, Claire. It's a pleasure to be here. Well, I think that there are really many theories of everything, and there have been throughout history and in many different areas of human endeavor and interest. So, for example, perhaps the one that's most salient these days is a potential theory of everything that would unify the sciences. And, you'll often see at the beginning of a physics textbook, some claim to the effect that, they've discovered the 4 fundamental interactions. There might be a new one I hear, but, and those in operation, massively complex combination along with the particles and other sorts of interactions that are associated with those serve as a basis for, everything else, chemical goings on, biological goings on, maybe also psychological goings on, and so on. So that's one sort of project, according to which the fundamental physical goings on in massively complex combinations somehow serve as the basis for all else. And there's different ways that could operate, right? And then on the other end of the spectrum, there are, I think, religious and more broadly, say, spiritual sorts of visions of, how everything hangs together. And so, for example, in the Abhidharma Buddhist tradition, there are, 7 simple sorts of property particulars that in causal interaction serve as ultimate basis for everything else, and everything else is kind of conventionally real. But the fundamental reality is unified by these kind of 7 different little bits of feeling or body, etc. And then another kind of religious sort of theory of everything you might think of in the Christian tradition, for example, is one according to which I think this expression is so beautiful. We live and move and have our being in God. So the idea is that, God is the one necessary substance and we are something like modes. Everything else is kind of a mode or a property of God. And then in between those two kind of very different projects, there's, I think, many philosophical theories of everything, broadly in the metaphysical tradition, and these can shade into more scientific or more broadly spiritual sorts of considerations. So just to put a few examples on the table, Democritus, for example, ancient Greek philosopher, thought that the fundamental goings on were basically atoms in the void, and atoms in massively complex combination, et cetera, could serve as the basis for all else one way or another. Sort of a contemporary updated scientific metaphysical theory is physicalism, many different versions of physicalism, but also taking the physical goings on again to serve as a fundamental basis for all else one way or another. And then shading more to the spiritual end of the spectrum, so to speak, might be Berkeley's idealism, according to which all that exists really are minds and ideas, such that we are we are all somehow contained. Tables are ideas in God's mind. We are somehow also contained in God's mind. So those are all theories of everything. And I think they have in common that they aim to understand or explain reality in some kind of comprehensive and unified fashion. And I think they also have similarities, structural similarities as well, but I'll stop there.
So lots of different options for how to go about a theory of everything there.
Exactly.
In terms of kind of trends, are there trends towards thinking of these kind of theories in specific ways, especially maybe in contemporary science and philosophy?
Well, I do think that people are starting to think in terms of a kind of, as I was saying, a structure that is common to theories of everything, where if you'll notice when I was giving all those examples, there's typically some kind of, set or collection or, configuration of entities that are taken to be fundamental or at least relatively fundamental. And so, one question associated with these theories of everything is sort of like, well, okay, what are you taking to be foundational in your theory? Sure. And then, there's this other question about how everything else that's not part of that, special collection, so to speak, how does it metaphysically depend on the things, the goings on that are fundamental? And there are just a lot of different options. So at least in, I think both in the sciences and philosophy in particular, there's a lot of action in trying to figure out, well, first of all, what should we think is fundamental? And also philosophically, the question is like, well, what is it even to be fundamental? What are the, is fundamentality somehow a matter of you not depending on anything else? Or is it rather a matter of you serving as a basis for all else? Or maybe is it even primitive? And then this question about how other things depend on what's fundamental, that has even more candid answers. Of course, when we talk about reduction, Vanessa can especially speak to this, but identity is sometimes a relation that's brought to bear such that, really the table is identical to some complex configuration of molecules or other physical goings on, et cetera. But identity is not the only option. And a lot of action in contemporary metaphysics these days concerns accounts of dependence of higher, what's often called higher level phenomena, like, the things that would be, that we experience, for example, macro phenomena. What are our options for understanding how those are related to more fundamental phenomena? So tons of interesting stuff going on that way, but that common structure of, some kind of fundamental base, and then these questions about how other things depend on that fundamental base, those are real interesting areas of live action these days.
Is it cheeky to ask, do you have a preferred theory of fundamentality yourself? Is there one in particular that you think? No,
thank you for asking. I'm actually a primitivist about what it is to be fundamental. And that reflects that in part because I'm interested in all these different theories of everything, and I want to have a philosophical account of what it is to be fundamental that is maximally ecumenical, that makes room for, for example, suppose God is fundamental. God is the only fundamental entity, and God depends on God's self. I think that seems to be a live option. Some people have and continue to believe that. So if that's true, then an account of what it is to be fundamental, according to which you don't depend on anything, doesn't clearly accommodate that, right? There's moves you can make. And similarly, I think that, the idea of the fundamental goings on is serving as a basis for all else. I think that is, that's some part of what it is to be fundamental, but I think that, that in a way is what the fundamental does. It doesn't make these things fundamental. What makes these things fundamental at a world in a way that's, to me, that's axiomatic, is primitive. And then once you've got those fundamental goings on, then they can go ahead and do their work in bringing the rest of reality around.
Okay, thank you so much for sharing that. We talked a little bit about physical reductionism, or sort of gestured at it. Vanessa, would you mind sort of telling us a little bit about that? What's the background to it, and what does it look like in physical theories?
Yes, of course. Thank you for having me here, by the way.
Very welcome.
So reductionism is the idea that a set of concepts or entities are related to another set of concepts and entities in such a way that the former are either regarded eliminable or just secondary in some sense with respect to the latter set, right? Now the idea started primarily it started with respect to scientific theories. So how scientific theories relate to each other and whether we can reduce all the scientific theories to one scientific, to another theory, right? So we start with like the logical positivists who talked about reduction as translation, where you would have the language of one theory being translated into the language of another theory.
That's sort of 1920s, 1910s?
Yes.
What? Okay.
Carnap and Neurath would talk about reduction as translation in that sense. There would be an implicit kind of ontological assumption there that there is something more fundamental, and that is why we can translate everything into one language. But officially, at least, the aim was to kind of to simplify to have linguistic parsimony, to simplify things, but also to kind of accommodate interdisciplinarity during that time. So we've got like different scientific theories employing different languages, and this would make it difficult to communicate between those theories and to restore potential gaps between them or even inconsistencies that might appear. So they wanted to advocate a sort of reduction as translation in order to resolve these issues, right? But then they started kind of to catch on in philosophy. And then we have like Ernest Nagel, who talked about reduction in terms of derivation. So this was more a more robust account of reduction, where he would talk about how the laws of physics could derive the laws of the special sciences, right? So his classic example would be how you could derive the laws of thermodynamics from the laws of statistical mechanics. And this could be achieved in a more broader way. Of course, translation would be one way to do that, of course. But then he would argue that even the existence of empirical hypotheses that could connect the concepts of one theory with those of another would suffice in order to have a derivation in terms of, a reduction rather, in terms of derivation. Of course, this was a kind of, this is often called in philosophy a strict form of reduction. It had very strict requirements upon our scientific theories that didn't seem to hold up in practice. And so the reduction continued to evolve, and we had reduction in terms of explanation later on, where you would say that, you know, you have reduction when one theory can explain the phenomena of another theory. So for example, physics could, the laws of physics could be employed to explain chemical laws or biological, chemical phenomena or biological phenomena, right? So and this, according to some philosophers, would suffice in order to say that you've got reduction. Of course, there were many challenges addressed to that. I don't know if you want me to go there yet or not.
Yeah.
How it's all started. And then there were objections against these forms of reduction, most standard being the one about multiple realization. So it was often argued that
Can you say what multiple realization is,
yes,
just for those of us who don't know?
Yes, so multiple realization is this idea. So we've got phenomena like pain, say, right? And so if you have reduction, then what has to happen is that you have to explain pain in terms of the physical things that make it up,
Okay.
right? But then it turns out that a lot of different entities feel pain. So there are more than one physical basis that one could invoke in order to explain pain. And this seemed to kind of challenge strict notions of reduction, because then it wouldn't be able to connect one specific physical basis, physical goings on, in order to explain higher level phenomena. And this was a huge kind of challenge against reduction. But then reductionists didn't really give up. Because even despite those challenges, it was argued that, you know, we might not be able to identify very specific relations between our scientific theories, but we can still maintain the claim that everything is made up of physical things. So this brings us to ontological readings of reduction, in contrast to theoretical understandings of reductions, which were the initial ones. So philosophers would say, you know, even if we cannot build translations between languages or have empirical hypotheses that connect our concepts, the molecules or genes or proteins are essentially made up and explained by atoms and electrons and, you know, the things that make them up, the physical things that make them up. And this is called ontological reduction.
Okay, I'm just thinking it sounds a lot 20th century. Physics changed a lot over the course of the 20th century. Did that play a big role in the way people thought about this project, or?
Immensely, it did, yes, of course. And it is interesting because if you kind of get a larger overview of how the views of philosophy about reduction changed, they changed in tandem with the changes in science, right? So at the beginning with quantum mechanics, with the advent of quantum mechanics and like the development of computation, we kind of had this belief that everything could be explained by physics, right? So there's this very famous quote by Dirac, who said that, you know, you can explain the whole of chemistry can now be explained by quantum mechanics, and it's only a matter of how we can compute these things and solve the physical equations in order to get, you know, results about chemistry and biology and so forth. And this kind of motivated and supported the beliefs of philosophers that, you know, you can actually have reduction in practice as well. But then, you know, the more science is developed, the more we understood how complex phenomena can be, and that in practice it's actually difficult to compute biological phenomena or even chemical phenomena. And this was accompanied, you know, by a sort of skepticism against reduction as well.
Okay, speaking of reductions from chemistry to physics, do you mind if I ask you a little bit about your PhD? I believe you did some translations or some reductions from the chemical level to physics there.
Yes, thank you for asking. Yeah, indeed, that was actually my main, the main thing that I focused on in my PhD was understanding the relation between chemistry and quantum mechanics. This is a very nice case study with respect to reduction, because chemistry and physics are very much connected to each other. It's an example where you have a whole field called quantum chemistry, which is devoted into solving quantum mechanical equations in order to explain chemical phenomena. Yet at the same time, chemistry is still such a strong, autonomous field that produces so important predictions and explanations on its own. So you, well, no, I don't want to say as a reductionist, but as a person who is interested in inter-theory relations, this is very intriguing, right? Because you have a very strong sense of autonomy for a higher level of science. And at the same time, you have very strong interconnections with a more fundamental theory. So that's what I like to explore in my PhD.
It's fascinating. I don't know if anyone else would, please feel free to speak at any stage. Philip, if I could move to you maybe for a minute now. You've sort of worked in a lot of different areas of science. A nice kind of general question to think about might be what we want from our best scientific theories, or, you know, what we want a good scientific theory to be doing.
Yeah, and that's a very good question. I want to say, first of all, actually, I'm also very pleased and grateful to be invited along to this, as much as anything else, because it's so useful and interesting for me, coming from a scientific background, to hear what philosophers are really thinking. Philosophers are thinking much harder about these questions, I think, very often than scientists are, and it's really nice to see that. And you see, I think that's going to relate to my response to your question as well, Claire, because, you know, most scientists are very pragmatic. And so what they want from a theory ultimately is something they can use. But that has some strong ramifications for what the constraints are, because they want a theory to be simple in its assumptions. They don't want everything in there. In fact, they want to get rid of most things and be able to focus on just those aspects, just those parameters that are likely to matter in their situation. So it's going to be a simplification. It's going to be a model of the real complexity of the world that everyone recognizes. They want it couched in terms that are meaningful to their field. And I think that's really crucial. And actually, I think it turns out to be quite important for this whole question of what is reducible. And they want it to also be a theory that can be used to address questions that are meaningful in their field. You know, and sometimes you find that someone coming in from outside of a field with a theory, it turns out to be a theory that actually doesn't address the questions that people working in that area think are the important ones, the relevant ones. So those are what I think scientists generally are looking for in their theories. And what that sometimes means is that the things that are meaningful to their field aren't ones that lend themselves to easy reduction. I mean, if we think, for example, of going, we've talked a little bit, and you know, Vanessa has talked about the relationship of physics and chemistry. I want to say a little bit about that. But if we go all the way to beyond biology, even to sociology and anthropology, you know, the idea here is that you would get this hierarchy, and eventually you get there, and you get theories that explain us and our societies. In psychology, for example, the kinds of things that are meaningful to psychologists to think about are, you know, people's motivations, people's sort of mental states, their emotions, which actually it's not at all clear that those sorts of things can be reduced to brain states. There isn't a unique brain state that we know of. I don't think there is a unique brain state that can possibly exist to explain someone's motivation for, say, you know, wanting to get a reward. You can talk about the neurotransmitters involved. That's not helpful to a psychologist who factors that into trying to understand people's behavior. So I think that's sometimes a problem. And I think you can even see it in, for example, crossing from physics to chemistry. You know, I was very interested to hear, and I knew about this, what Dirac had said about all of chemistry now being explainable by physics. Dirac was clearly not a chemist, because no chemist would say that. And one of the reasons you would say that is that, you know, it's not all about quantum chemistry. What most chemists are doing are finding out ways of building molecules and doing things with molecules. But in order to do that, they have to make use of concepts like chemical bonds, like, say, electronegativity, you know, properties that describe the chemical elements, that aren't well defined in physical terms, but they're useful heuristics for chemists to work with. Not just useful, I think they're essential. There is no unique agreed definition of a chemical bond. So the idea that you can explain chemical bonds by quantum mechanics, you know, you can explain a lot about certain kinds of chemical bonds, covalent bonds that hold atoms together in carbon, say, but it's not even clear what the different categories of chemical bond are. The periodic table is central to chemistry, and there's a lot about it you can understand from quantum mechanics, but actually there's a big discussion in the philosophy of chemistry about whether the periodic table is ultimately determined by quantum mechanics, or whether there are some aspects of it, where to put this element relative to another one, that actually come down to a matter of taste and pragmatics, and, you know, what serves chemistry best. Thing resolved by using quantum mechanics. So I think that, you know, simply thinking about what a theory needs to be for a science immediately raises questions about whether it can be meaningfully reduced to a simpler level of description.
Okay. Strikes me that you guys might have something to say. Sure, yeah.
Yes, actually, that's very interesting. If you look at the history of about how quantum mechanics came about and reactions of chemists, is exactly what Phil says. You know, chemists at the beginning were very felt awkward with quantum mechanics. They didn't know what to do with this, right? And then came in Linus Pauling, who really wanted to show chemists how they could use this, and how you could employ quantum mechanics in a way that is meaningful to chemists. And he actually did achieve that for a certain period. He developed a whole kind of model within quantum mechanics that will give you things like the chemical bond translated, rather explained in quantum mechanical terms, but yet useful to chemists. But then, you know, this kind of faded. after the development of other quantum mechanical models that pushed away those concepts that were meaningful and intuitive to chemists. So it's indeed, there's kind of there's a clash between the two. For some.
Vanessa, you also, in that regard, you raise this crucial distinction in my mind between what is simply practically too difficult to do. And, you know, it's true that in quantum chemistry, it's immensely difficult to get a full quantum model of even, you know, simple molecules like methane or something, let alone, you know, biological proteins that you might want to use to understand how a drug behaves. But in principle, there's a sort of an agreement that, you know, you could do it if we just had the right amount of computing power. And there's a distinction between that and the question of whether you can make that translation in terms that are meaningful to chemists. If they want to decide, is this a bond in this molecule, whether these two atoms are close together, or is it not? Are they just kind of feeling each other, but it's not really a bond? There's no answer to that necessarily that quantum mechanics will give you. It all depends on what definition you want to choose for a bond, and you know, there's no consensus about that. So, you know, I think that sometimes this question about reductionism, you know, gets sort of stuck on the question of, well, you know, maybe we could do it in principle, but not in practice. But I think that sometimes there are more fundamental problems also with that translation between disciplines.
Yes, but I agree. But especially for the case of the chemical bond, the problem, at least for me, is not reduction here. It's the chemical bond itself, because it's not just the quantum chemistry cannot give you a definition of chemical bonds. Even within chemistry, it's very difficult to point out what chemical bonds are, right? So it's a very not a problematic. It's a very ambiguous concept in chemistry to start with. So I'm not sure whether the problem here is with actual reduction or with the fact that there are certain concepts that within the higher level sciences are not very well defined yet. So yeah, I'm a bit skeptical about that.
Yeah.
Oh, please.
Yeah, I would agree with that. But I will say, though, that considerations of the sort that Philip is raising also give rise to a kind of standard dialectic between those who want to try and take these appearances of higher level, you know, reality as autonomous somehow or another from, you know, lower level, usually physical goings on, or those who just want to give a pragmatic spin to them. So this is, you know, this is a real, you know, ongoing question. But there are people who would want to say, you know, once we have more or less fixed that what we're talking about is something like a chemical bond, and we have some idea of, you know, what it does in certain contexts, you know, however exactly you want to define it, so long as you're confident that, you know, these bonding processes don't involve anything fundamentally novel, right? Nothing strongly emergent. That's a phrase that sometimes gets bandied about. You know, then there's this further question of, well, you know, is it really just, you know, an epistemic and epistemological or, you know, broadly conceptual matter that, you know, chemists find it more convenient to think in these terms? Could, in principle, this just be nothing but lower level physical quantum goings on doing their thing? Or is there actually a level of chemical reality, so to speak? And if so, what exactly is the relationship there? If it's not identity, if it doesn't collapse all down to the fundamental level with all the seeming hierarchy, really just a matter of our convenient, you know, what's convenient or practical, then what are the relations that could serve to support there being some kind of non-reductive structure to natural reality?
We've sort of given a little bit of a gloss of how emergent phenomena might play a role here, or why emergence may sort of complicate things. Like, Philip, would you be up for saying a little bit more about that and how it might play a role in these kind of theories?
I mean, it's one of those terms that is bandied about a lot, and it's never never entirely clear what different groups mean by it. I guess, certainly in terms of what Jessica has just said, I think one of the key questions for me is I suppose it's really the ontological status of things that we talk about as being emergent. So, for example, if we come, the interesting thing in a way about chemistry and the chemistry-physics interface is that they're so close and there are so clearly connections between them, and you can use quantum mechanics to say a lot about chemistry that, that allows you to have a certain level of discussion. But if we go to something like psychology, for example, the question sort of becomes, let's say, is our desire for social status a genuine ontological thing that causes us to do things? Because if it is, it's a problem, because you're not going to get that reduced into any quantum mechanical terms, not just because it's too complicated, but because it simply can't be defined in those terms. It will vanish at that level, if it means anything at all. So I think that's what I'd be interested to hear from you guys about. That, what is the thinking about the real ontological status of the things that, for, let's say, a psychological theory, are spoken of as real causative forces? That, to me, is really the question of emergence. Is there a genuine sort of causal ontological reality to the things that we talk about at those higher levels, if you like, as causes of things to happen?
Good. I could speak to that. Well, first of all, I think it's useful to observe that there's at least two different conceptions of emergence that might be at issue. And one of them I already mentioned, which is, sometimes called strong emergence or robust emergence. And that kind of emergence would, suggest that something, as I said, fundamentally novel is going on. So sometimes people think that qualitative experience or consciousness, maybe free will, et cetera, this is not so much a matter of definition, but it's just like the nature of those phenomena are such that there's really no hope in cashing those out metaphysically or ontologically in terms of, purely physical knockings about. But then there's a weaker form of emergence, which is compatible with a kind of physicalist view, according to which, you want to say the only fundamental goings on are ultimately physical. But, there really is, these guys are different from those guys. They metaphysically depend on them, but they're different. And there again, definition is not really to the point of trying to cash out that form of emergence. But the question is, how do you, like Philip says, how do you make sense of that causally? Now, if you have strong emergence and you have something fundamentally novel, there's no mystery in seeing how it could be causally impactful, right? Because as long as that fundamental novelty brings with it new powers, new fundamental interactions, new laws, and so on, that's cool. But for the most part, people have shied away from thinking that there is very much strong emergence, just because there's not the kind of empirical support for it that there is, for this other form of emergence, which is often called weak emergence. And there you have something like, for example, functional realization might be a kind of paradigm sort of relation there. So in the case of psychological phenomena, when what was your example, Philip?
Well, let's say, I think it was something about, social status. Sometimes we do things because we desire social status.
Yeah, great. Okay, so, if you can try to give a sort of functional characterization of that in context of certain social practices and so on, and if you can assign a kind of functional role to some higher level phenomena and associated causal powers, right? And then coupled with what Vanessa was talking about earlier about multiple realizability, this idea, software, hardware is sometimes used as an analogy. So a software program, it's supposed to do certain things, but it can be run on many different hardware formats, right? So similarly, you might think this desire for social status, it's got certain powers, that are associated with its functional role. It might lead me, it will cause, if I want this, I'll do these things. Certain kinds of causes and effects might be characteristic, broadly speaking, of this kind of mental state or this kind of aim. And those are powers in the world, they're causal powers. Now, if you're a physicalist, and a weak emergentist will be a physicalist in this case, they will say, look, this kind of mental state is different from any complex lower level physical states, not identical to a brain state or anything else for a bunch of different reasons. But the powers that are associated with this mental state they're not anything fundamentally novel. There's no strong emergence here, right? It's just that there's really these massively complex physical goings on with their powers. And these powers, each one of them is different. Each one of them is identical to some power or some massively lower level complex physical phenomena. But the powers that are associated with this particular mental state are they're actually fewer. There's a proper subset of powers associated with that mental state relative to the brain state or the ultimately fundamental physical state that's associated with my mental state on a given occasion. And this difference in the power profiles provides a basis for the mental state being different from the physical state, but it also renders it possible for it to be causally efficacious as well. So sorry, that was a little bit of a technical answer to a kind of metaphysical question of how you can, in fact, make it the case that some higher level phenomena are, in fact, sort of causally implicated without having to posit something like strong emergence and fundamentally novel powers at the higher level.
I might take this opportunity, if I can, to remind people, if you would like to ask a question, you can do so either in Zoom if you're using Zoom or on the comments section in Facebook. So yeah, please get those in. Vanessa, these kind of emergent issues, we've talked about them a lot in terms of relations between things as small as quantum mechanics and then things as kind of esoteric as psychology. Do you get many of the same kind of issues in these more sort of ontologically intimate, areas like chemistry and physics?
Yes, of course. They underwrite all levels and all sciences. These are universal problems in a sense. Especially the problem of causation for me is, I think, the most difficult to solve and to kind of accommodate either from a reductionist or an emergentist perspective. How to reckon, because this has to do, so there's an implicit assumption here that philosophers often hold that for something to be real, it has to do stuff, right? So it has to figure within explanations and it has to figure into causal relations. And this is a problem with accommodating higher level stuff, right? Because we assume that for them to exist, they have to cause things. Yet if they do cause things, then that means that there's something over and above the physical things that make them up. So this is a problem in chemistry as well, of course. So a classic example of this is molecular structure. So it's been argued that the strongly emergentist views in chemistry argue that the structure of a molecule, its geometry, emerges at a different level and actually constrains how the physical the physical entities that make it up are going to behave. And this is the sense in which it is something over and above those physical entities, and this explains why quantum mechanics on its own cannot give you that geometry, right? You always have to assume what kind of geometry you want to describe in physics in order to get that out from the equation. So yes, it's a huge topic.
Okay. I don't know if anyone else wants to weigh in on that. I'm happy to move on if not. Okay. Oh, Philip, did you?
Well, I mean, yeah, this could unravel, indefinitely, I guess. Maybe you were going to move on to this, Claire. Anyway, It felt to me like at the moment we've been talking sort of quite platonically, I would say, in terms of things like the shapes of molecules and so forth, or brain states that exist in some sort of abstract realm. Whereas certainly once we get on to the question of chemistry becoming biology and biology becoming behavior, anthropology, whatever you want to call it, we can't avoid getting history involved in whatever explanation we have of causality. And I think this too seems to me to be something that creates a tension in ideas about reduction, because there's this common view, and I've heard it said very recently that all of biology can be explained by chemistry. If you take that seriously, then you mean all of evolution, all of us, that we can be explained by chemistry. That can never mean that by finding out where every single atom or quark is in our body, we have somehow explained ourselves, because a meaningful explanation has to be a historical one. It has to take account of the evolutionary trajectory that has got us here and has got these molecules into these particular arrangements. There, I think, once you start to have any kind of science that requires a historical kind of answer, it becomes problematic to the extent of probably impossible to develop a sort of reductionist explanation that doesn't in the end have to take into account everything that's happened since the Big Bang. Certainly in terms of biology, that seems to be the case. So I'd be interested to know, what happens in those cases. What happens to those explanations that are necessarily historical rather than sort of static or timeless?
So we are onto the issue of the appropriate scope of everything. So, I don't know, Jessica, Vanessa, do you guys have a sense that there is an obvious limit for people who are practicing things the way you are on how much you should try and explain?
Well, I could just say very briefly that, Philip is raising an excellent point, and the response to that kind of concern has typically been precisely to just expand the base of whatever the presumed fundamental physical goings on are, to embrace whatever spatiotemporal region is required unto the task. So they go broad, so to speak. But yeah, I mean, the idea that there's kind of, this is all very in principle, and it must remain obvious for obvious reasons. It is just understood to be in principle.
I mean, my concern about that is that once you realize that you have to go broad for that reason, there's no obvious place where you can stop before you have what is essentially an identity description of everything that's happened. Which in my mind could never be an explanation, it's simply of everything.
Well, I guess it would just depend, on the details of the case. You maybe have to go back until you've got the relevant biological entities, and you don't have to go back any further. But
one of the things that seems to be sort of implicitly in the background in some of the commentary is a little bit of a tension between pragmatic uses of scientific theories and what is sort of fruitful and useful for people who are practicing scientists to be having, and then much more kind of esoteric theoretical approaches to what exists and what is there. So I'm thinking that this may also relate to issues of epistemology and issues of what we might be trying to find out in practice versus in principle. So I don't know, I know Jessica, Vanessa, you too, Philip, I'm sure there's plenty to say, but can anyone maybe open up a little bit about what role epistemology plays here, or knowing theory of knowledge?
Well, for me at least, it's a bit difficult to specify what amount of sufficient evidence for a reductionist. It seems that we ask too much of our sciences in order to be satisfied as reductionists. It seems highly improbable to me that we will ever reach, even if there is reduction, we will ever have a scientific theory, a physical one, that will be able to specify the initial conditions of how the universe began and then kind of get the elephant in the jungle. right? That's impossible. So why should we put such strong constraints to reduction and say, well, you cannot give me the elephant, so there cannot be any reduction. We only have signs, epistemic signs, that we can interpret in different ways. And some ways are reductionist, some of course are emergentist. But I don't think we should ever expect to get like a definite answer in like I don't know, a book, like a theory of everything book, where it can give us all the final answers, right? So it's very tricky to specify what criteria would suffice. And a lot of the debates in philosophy revolve around what we should take, what the right criteria are, right?
Yeah, good. Yeah, I think that's all in line with my understanding as well. I would also just say that I think there's also, from my perspective, the work that I'm doing, I'm looking at kind of these general questions about how we should understand what it is to be fundamental, or what are our options for understanding how some goings on metaphysically depend on some others, how should we understand the varieties of emergence, and so on and so forth. So the question of epistemology enters in there, in trying to figure out, well, how, what would motivate one theory of everything over another? We've been sort of assuming, talking about mainly a kind of scientific theory of everything and what that would involve. But, more generally, one could just ask this question, well, what is, given especially the pragmatic limitations, what are the sort of, what's the methodology that we should be using in trying to arrive at a given theory of everything? And I think, for example, in the case of, just to go back to the scientific case, there's something like an inference to the best explanation going on in a lot of these cases. It's not really a matter of deducibility or anything that strong. So following up a little bit on Vanessa's point about, what would reasonably count as a decent explanation? It doesn't have to be a matter of derivation. That's too representational, and there's no hope of doing that. But what we could do is kind of come up with these sort of piecemeal, chain together a bunch of piecemeal explanations to try to figure out how that would work in one way or another. And what I do like, as by way of methodology, just in philosophy in general, but in particular in these cases, is like I said, something like inference to the best explanation, where, what's to be explained is why reality is like it is, right? Experientially, scientifically, and otherwise. And then a lot, as far as I can tell, what typically happens, whether we're talking about the sciences or these other sorts of theories of everything, is that there's a supposition. It may be speculative, it could be a working hypothesis or whatever about what's fundamental. And then you've got some goings on that aren't obviously part of the fundamental base, and you ask, well, what would it take to get these guys from these guys? And, one proceeds that way. If you can't understand how these guys, and I think a lot of Philip's comments are sort of along this line, it's like, I just don't see exactly how you're going to get these mental phenomena, for example, out of these phenomena, then that might lead one to revisit the initial assumption about the scope of what was fundamental. Maybe we need to throw in some novelty at a higher level, for example.
Jessica, could I ask, is it sort of understood that a theory of everything of that nature, would that be expected to be self-contained in the sense that it would generate its own initial conditions as well? That's the problem for me, that generally, the scientific theories we have, an explanation comes from the theory plus the initial conditions. But yeah, are you looking for everything at once?
Yeah, great question. No, maybe not, right? So every theory has its primitives, and you might think those initial conditions are going to be just contingently given, and the theory itself can't generate those. It can take them as input, but on the other hand, I say that, but there's kind of another active area of philosophical investigation, according to which there are certain kinds of considerations which suggest that the initial conditions at least have to be such and such, have, certain features. So I don't want to rule that out, but I just want to flag that, initial conditions might fall under the rubric of stuff that you just have to kind of take as given.
I ask Vanessa, as someone involved in reductionist schemes, is the thought more, it's not that we want to necessarily translate all of chemistry and indeed all of biology above it and sort of everything else into physics, but rather maybe to show the possibility of sort of either redescribing or of reducing, enough sort of chemical phenomena in terms of physics so that we can be confident that, such a thing would sort of be possible if we could do it.
Well, yes, but not even that. I would go even weaker in a sense. So for me, the motivation for a reductionist kind of view with respect to chemistry is to resist this this idea that there is something more than the physical stuff that make up chemical things. So an example I always use is like with people dancing. Forming a group like with the Greek dances and going around circles, right? So there is a sense in which the circle and the dance is over and above the people that perform that. And you could describe the shapes that they form and the rhythm in terms of the higher level, the music and all the things that they do as a group. But nevertheless, it's just a specific number of people that make up the dance and perform these, these group actions, right? So my motivation is kind of I want to insist on that, because it seems that in philosophy sometimes we want to get through this idea that actually there are more than the people that make up the group. When we talk about them, as a performing dance group, my example is not very good at this moment. Sometimes
it's a lovely example,
but this is my main worry with emergentist views, that you kind of want to put in stuff that are not there according to science, right? So in chemistry, for example, with a chemical bond, sure, you might not be able to explain the chemical bond quantum mechanically, but that doesn't mean that it's something more than, the Coulomb, the electrostatic forces between the protons and the nuclei, right? There's no other new force that kind of makes up the bond. And sure, quantum mechanics cannot give you the different types of bonds or cannot accommodate so nicely the geometry of molecules in ways that do not invoke chemical bonds. But that doesn't mean that there's something mysterious going on.
Really lovely explanation. I don't know, Philip, if you want to weigh in there as well, or?
Well, I'm interested, Vanessa, in whether, to hear that it sounds as though there are people who might contest that. I've never really had the impression in chemistry. I mean, there are certainly chemists who would resist the idea that somehow what they're doing is going to be reduced or explained by physics. But I've not encountered ones who feel that actually there's something more to these molecules than atoms, than protons and neutrons and electrons. But it sounds as though perhaps there are some who will suggest that there's some other essence that somehow arises from them but isn't inherent in the particles. Is that really what the suggestion amounts to?
Well, no, I don't think this is something advocated by chemists. I think this is more within the philosophical literature on emergence, but it's not. It's phrased in a bit vaguely. That themselves the chemical entities are something over and above. But what it is, that extra thing that makes them up, well, we don't really say, right? Talking to chemists, it's interesting. They would agree that molecules are not made up but nothing from electrons and nuclei, but they're very strong realists about what they do. They do believe in molecules and chemical reactions and substances, and you have to find a way to reconcile that with the fact that there's nothing more than, well, there's presumably nothing more than electrons and nuclei, and that's not a straightforward task.
Well, maybe I can suggest, I mean, just off the top of my head, that something where I could imagine an argument like that coming in, looking at a sequence of DNA. And some might say the information that is encoded in that it is information. If you took a piece of DNA from one of my cells, there would be information in there. One could make something with exactly the same kinds of chemical characteristics that had no information in there, in the sense that it couldn't be used for anything. It would be non-functional DNA. Is there something in one that isn't in the other? And if so, where did it come from?
That's interesting. Yes, that could be a way to argue in favor of emergence. I don't know. A reductionist will presumably say that it's a necessary. It's in the essence of the things that make up the DNA that will encode that information necessarily. You cannot. It's impossible to have a situation where you won't have that information encoded, I suppose.
I'd like to move to. Jessica, do you want to have a quick one, and then we move to audience questions?
Just a quick observation about the sort of considerations that might lead one to posit some goings on as strongly emergent in some way, that they would be genuinely over and above. We've been talking about sort of derivations or failures of derivations or so, but once we back off on that, we need some other criterion of when it would be that, we really do have something genuinely novel. And just to throw out, one suggestion, if you look at fundamental physics, when do they posit something fundamentally novel? Well, when there's an apparent violation of a conservation law or something like that. So that was what originally inspired the introduction of the weak nuclear interaction, for example. So, I think that might be one kind of actually empirically sort of salient possibility if we were wondering, for example, whether consciousness is genuinely strongly emergent or not. Notwithstanding that we don't have any kind of clear explanation, we might still end up thinking that it's not really strongly emergent if, in fact, we were able to perform these sorts of experiments. So I just wanted to sort of raise to salience that once we back off from theoretical reduction or any kind of, really intimate sort of linking of the concepts that would provide that sort of thing, failure of derivations no longer, show us where we should go one way or the other. We have to start looking at some other kinds of criteria for when we would have something genuinely novel. So that's one that I have advocated in the past.
I have a good question that I think is not unrelated to this. Apologies in advance for any names I butcher in reading these questions. I really will do my best, but I'm sorry. So Sam asks, if we discovered that ghosts exist, but it turned out that ghosts could not be understood in terms of any of our current best scientific theories, would ghosts count as emergent, or would they count as a new fundamental type of entity? Please, with all the questions, just feel free to weigh in,
Could you repeat the very first part of that question?
Sure. If we discovered that ghosts exist, but it turned out that ghosts could not be understood in terms of any of our current best scientific theories, would they count as emergent or count as a new type of fundamental entity? Yeah,
great question. At least as I have characterized emergence in my book, just released from OUP, Metaphysical Emergence. Emergence involves not just novelty of some sort, either fundamental or non-fundamental, depending if you're talking about strong or weak, but it also involves some degree of dependence as well. Not complete dependence, but, well, in the case of strong emergence, not complete dependence, but some kind of dependence coupled with ontological and causal autonomy. That is to say, you're different and you can, you're somehow causally distinctive. So in that case, if the ghosts were not at all dependent on any of the physical phenomena, then in that case, they would not be emergent. They would just be such as to be included in the fundamental base, I would say.
I would really look forward to the empirical testing around this arrival of ghosts. Do you guys want to weigh in, or will I move on? Okay, so here's a kind of hard question, but I think a very good one. So this is from Stuart. How does the theory of everything and the reductionism it implies relate to determinism versus fundamental uncertainty?
Oh, Hmm.
Or do you need to assume something like one or the other in beginning a kind of reductionist project?
Well, that's a very difficult question.
I think so.
I will give an initial answer and then you can correct me if I'm wrong. So I suppose being a deterministic theory or not is independent of whether. So a theory of everything could be indeterministic, in my view. It's not incompatible being indeterministic and being a theory of everything.
I'd agree with that. In fact, I think that, if there is anything like a theory of everything, at the moment it looks as though it will be indeterminate, because our best understanding of quantum mechanics suggests that that is the nature of things. Whether that gives you any kind of wiggle room to get to something like free will is another matter. And I think that's extremely contentious, but it does seem to indicate that anything like even an approximate theory of everything that we might imagine we have at the moment cannot be a fully deterministic one.
Okay, another good question from Robert here. And again, it touches on a lot of things that have been said as well. So why start by assuming physical particles are what is fundamentally real? This is a theory made by a human being. Why not start from our human reality and understand science as abstraction we make for different purposes? Jessica, I can imagine you have a lot to say about that.
Yeah, I love that question. Well, no reason why not to try, So I think that's in a way why I was glad that you asked me, Claire, at the start, about some candidate theories of everything, because there are many other competitors to one which takes the physical goings on, particles or fields or whatever they may be, as fundamental. So, I mentioned Berkeley's view, according to which, the fundamental reality is really minds and ideas. But there's another interesting view, which is consonant with the suggestion that we start with human reality. It's called Middleism. And philosopher Sarah Bernstein at Notre Dame has just got an article in Philosophical Studies, something I believe the title is there a middle level or something like that. So what if we take, or fundamental middle level, I think she calls it Middleism. So what happens if you take, this level of reality, so to speak, as the fundamental, and then you would decompose down or compose up, so to speak. And she makes a good case that it's at least a coherent theory and it might have certain attractions.
Like Russell maybe said something similar about mathematics as well. Like, the 1 + 1 = 2 domain is pretty happy, but transfinite, infinitesimal, a bit trickier. Here's another question from Mustafa. So how would you test theory of everything? Or would it be testable at all? So maybe Philip, if somebody sends into you at Nature their theory of everything, they've got it handled. What are you looking for in peer review?
They do regularly every week. I mean, I'm not at Nature anymore, but I saw enough of those to last a lifetime. How do you test it? You test it in the normal way. I would imagine that you test anything in science. You simply have to ask, what are the predictions that this theory makes that are, I don't want to fall back too hard, too easily on the Popperian view, because it's not the only one in science, but it makes a lot of sense in a case like this. You say, what does it take what is a discriminating test, a discerning test of this theory? It's on the onus of the theorist to come up with that, to come up with a test that will discriminate it from other ways of existing ways of looking at the world, and to do those experiments. So I think in principle, there's absolutely nothing that would you would ask of a theory like that you wouldn't ask of any scientific idea or theory.
Okay, so for the more, I'm trying to think of what tests Berkeley's metaphysical scheme, is it sort of coherence?
Well, for me, yeah, exactly. So I think that, a lot of the metaphysical theories, a lot of these theories of everything actually aim to be broadly empirically equivalent. So predictive, it's very hard to find the crucial experiment for a lot of these for a lot of these theories, because they're just set up in such a way that, you know, they can generate the observation, so to speak. So I think, at least in many cases, I think the confirmation proceeds again by way of an inference to the best explanation. But this is also in good standing in scientific terms, because I think a lot of scientific theories themselves, especially fundamental physical theories these days, many of which, you know, are the ability to test between variants of, for example, string theory, are just not available. So they have to rely on some other, you know, reason to go one way rather than another. And there, I think, you know, we have these various theoretical desiderata or principles. You know, I think someone mentioned systematicity or unity, fruitfulness, coherence, of course, as Claire mentioned. That may be the first one, just make sure there's no tacit contradictions and so on. Elegance, plausibility, all of those enter into the overall assessment. But, you know, the methodology here is not 100% clear. It's a messy process, and people disagree sometimes about the weightings of these principles. For example, ontological parsimony. Some people think, oh, if I have only a few entities and I can, you know, I may have a lot of complexity in my theory, but I've only got a few entities, and that really, that makes me feel good. But
I don't assume many things. Yeah.
I think one of the problems with a theory like that is that it will presumably be designed to explain what we see already. You might be up against the same kind of challenge that you have in deciding between interpretations of quantum theory, of which there are many, all of which only exist in order to be consistent with what we see of quantum physics. So, you know, this is the problem, that their whole aim is to explain what we see already. Finding something, you know, finding some respect in which they differ from one another is extremely hard. The same is true for theories of consciousness, actually. So, you know, for theories of this nature, I think that becomes a particular problem. You know, if they're trying to explain what we see already, you have to come up with something that is going to potentially conflict with what we see in order to test them.
Okay, well, this relates to a question, because the C word has been raised, from Kerry. So where would consciousness sit in a theory of everything? Is it physical, chemical, metaphysical, or everything?
That's a hard example, right?
Yeah.
I'm interested in coming back to this issue of starting from where we are. You know, it sounds like the sort of old-fashioned phenomenology, really. I think what's really interesting to me is that some ideas in consciousness have decided that's what we have to do. That rather than trying to figure out how it arises from the bottom up, from neuronal activity, we have to start with experience. That is really, you know, all the data, if you like, that we have on actual consciousness itself, rather than underlying neural behavior. And so there are ideas that try to start from that. And to build out from there, to start off by saying, well, what is an experience? What are its qualities? You know, the fact that it's unified, the fact that we only experience one thing at a time, qualities like this. And then from that to try to build a theory of consciousness. So, you know, that's not going to be a theory of everything, but in a sense you could say, well, it is a bit like that, because, you know, it's the theory of everything that we can experience.
The right theory. Yeah, sure, Jessica.
Yeah, just on that, starting with consciousness idea, and this also connects back to a previous question. There's at least, well, there's many different theories of consciousness, of course, as Philip was pointing out, but one of them sort of takes as its starting point, you know, the experience of consciousness, and then says, look, consciousness, the nature of conscious experience is such that there's no, even if we have a flexible epistemology of the sort that, you know, I think Vanessa rightfully says that we have, there's just no way we could get from just the non-conscious physical goings on to the conscious physical goings on. There's just no pathway, even in the most broad explanatory terms, to go from there to here. So they say, okay, well, I guess we better go backwards and put consciousness down at the fundamental level one way or another. And this is associated with what's sometimes called panpsychism or proto-psychism, which until recently was not a theory of everything that had gotten a lot of traction, but recently there's been quite a lot of interest in that possibility, basically because it's been very let's say inconclusive how to accommodate consciousness in a physical world.
Okay, I'd like to mention, because it has sort of come up already, but just Dwight's question was, can a physicalist avoid panpsychism, the view that the mind in some sense is fundamental and ubiquitous? It seems that this physicalist is committed to panpsychism, for if she's a weak emergentist about the mind, then she believes mental states as we see them in living organisms are not ontologically novel. And so it seems that the mind has to be fundamental in some sense. So you can see, I just wanted to point out a kind of relationship between the question that was asked and where we come to. I have another question, maybe this one for Vanessa. So this is from Javier. Do you think that the positivization of the sciences during the 19th century has produced the problem of reductionism? And they're wondering this because until the 18th century, metaphysics was very important for explaining how science works. And I know that kind of touches on maybe something we emailed about earlier.
Partially, yes. And partially, I think a great contributor to the debate was also the huge development of science at that time. So the idea of reduction was, of course, kind of motivated by logical positivism and this debate about what is meaningful and not meaningful and how we can distinguish between the two. But I think that the greatest role was that of science itself, because at the beginning of the 20th century, well, at the end of the 19th and 20th century, then the development of science grew like exponentially, right? Especially physics, we've got like relativity theory and quantum mechanics, and then we had the development of computations and complex mathematical methods. And I think this is the main kind of thing that boosted reductionist ideas. But yes, I agree.
Maybe the space between philosophy and science as well now is an issue. I'm just thinking of, late 17th century and Newton, again, just very much the cutting edge of both, and thinking of Locke or somebody in the 18th century who really sees himself as just cleaning up some of the conceptual stuff around Huygens and Newton. So I wonder, is it a sort of interdisciplinarity again we need to help push some of the sort of grander theories forward?
Yes, look, well, during that time, I think when you said that you were doing philosophy, you most of the times you may have meant that you were just doing science, right? So there was interdisciplinarity in terms of identity. There wasn't, science wasn't distinguished from philosophy in a sense. And, Aristotelian metaphysics very much influenced our views of the world and what it is made of. So they were one and the same for quite some time. And afterwards, with the fragmentation of science and the separation through Newton, then we had, we could say that we kind of had a divergence between science and philosophy.
Okay, so if they think of Leibniz as the last polymath, maybe there's this sense that he could try and say something about everything because he had, the sort of knowledge raw materials available. A great question here from Austin. Could part of why there isn't unification of theories be because of things like the limits of various languages and limits of certain ideas that can only be expressed mathematically? Hugely complicated issues there.
Well, that's a very interesting question. There's if you disregard physics for a moment, you will see that both chemistry and biology and the other higher level sciences are not so mathematical as physics is. So yes, I'm not entirely sure. Language certainly does constrain the question. But I don't think it comes down just to a matter of how. I don't think the problem lies in how we phrase our statements about the world.
Jessica, is that something that kind of props up in your work, sort of limitations imposed by the linguistic and mathematical structures available within which to sort of produce these theories?
Mainly by way of inspiring an alternative, properly metaphysical approach. So I'm a big fan of keeping the representation reality distinction firmly in mind. And yeah, you know, representations are great, but they can fall down and, you know, fail us just when we need them most. So I think actually it turns out that that's not always the best way to go. And I think this is explanatory of why we moved away from these concerns with theories of everything pitched in representational terms, and intertranslatability or bridge laws, et cetera. And now are most of us thinking in terms that are more broadly ontological.
Well, all that remains is for me to reduce this event to a close and to give my very fundamental thanks to our panelists and everyone who came to watch. So thank you so much for joining us this evening, and hopefully see you again soon. Thank you.
Thank you.
Thank you.